First order nonlinear option convergency criteria, maximum number of iterations, user guide, default 100 tolerance, default 1010 thousandths, one ten thousandths relative to the default on relaxation factors. Relaxation actors control the amount of the nominal compression tension only the brace will undergo with the remaining activity during the analysis iteration, improve the convergency for the rare problematic models loading situation in which otherwise most all of the braces may experience the compression becoming inactive, causing instability, preventing solution. When converged tensions only on braces will start only either have zero or tension forward for the process is entirely automatic by default. Anticipated factors will not require manual editing for more circumstances. User break relaxation factors for tension only element. The default cleared maximum relaxation factor a tenth, minimum relaxation factor a tenth, maximum relaxation factor 5/10 of the mode still feels converged while you have the relaxation factor expanding allowable range by changing above the maximum values may produce convergencies. Relaxation factors are not activated by default, but they anticipated they will not recover the majority of the model's addition since the solution process with necessarily more complexity can increase the analysis of the time to degree. Second order nonlinear option. The options are available identical for those of the first order nonlinear. First order vibration option extraction method, the Jacobi iterative transformation method to calculate UGN values, UGN vectors, good for small models with an unstable, more medium, and large model with a subspace. Iterative simultaneously vector method to calculate the smallest EGN values corresponding with the EGN vector suitable for quickly finding the lowest frequency with a medium to large model with feast. UFeast algorithm effectively calculate UGN values specifying with a range suitable for the inside of the structure. ECS, US mass, LEDU, polyviz, feast for more information. Automatic. Initially, some of them use subspace to find lowest modes with the stopping criteria, either mass or the number of the modes not met for the feast. For this, then automatically you find higher modes until the stopping criteria is fulfilled. Stopping criteria, the prevent analysts continuing in favor of either of these criteria are met with the analysis will now look for any modes. Automatic number of modes. The option is selected with a specified the mask per participation required. Each of the direction option will specify the initial number of modes, which should be close to the actual number required in order to speed up the analysis process. For the total number of the modes, the automatic number of modes cleared with a specify the total number of modes required are default 10. The Jacobi setting, the maximum number of sweep at the transformation, every off-diagonal global matrix of the set, maximum number of the sweeps allowed, sweep tolerance, end of the sweep value checked against the previous sweep results. If the difference is less than the tolerance result of the conversion of the analysis is complete. Subspace settings, maximum number of the iterations to perform tolerance at the end of the iteration value of the checked against the previous iteration results. If the difference is less than the tolerance of the result, converge the analysis is complete. Feast, an initial search range, the specify the initial range value of the feast will search for the EGN value of the overestimating multiplier with each of the range. So if the initial guess for subspace dimension to be used and overestimated predicted number of modes in the range, maximum modes of the range, of the maximum level of the modes in the range, more modes of the found with the range split with several smaller ranges. Minimum search range is smaller than those no longer be split, even if the max number of their modes is greater than allowed. Second order buckling operation, maximum number of iterations, default 1000, tolerance, default 100 thousandths, maximum number of sweeps 50, sweep tolerances 1.E12, modes default show negative bulking factors, default no extraction method. Jacobi method is best, more suited for the small model. Subspace method is more suited for the large model. With the closed automatic for the program to determine the most appropriate method of your structure. First order seismic operation extraction method. Jacobi, the underrated the transformation method used to calculate the UG values, UG vectors, good small model with an unstable medium to large model. Subspace iterative simultaneously vector method to calculate small UG values corresponding UG vectors suitable for the quickly finding the lowest frequency medium to large models. Feast, use feast algorithm to effectively calculate UG values specified the range suitable for the any of the sign with the ECS.US mass LEDU polyz fest. For more information, automatic initially subspace for the final lowest mode in this criteria, either mass or number of the modes. Feast is automatically used to find with the higher modes until the stopping with the criteria is fulfilled. Stopping criteria is prevent analysis continuing forever. Either the criteria are met, but the analysis will not look for any other more modes. Initial number of the modes. In order to speed up the analysis process, you can specify the initial number of modes that expect with the required to achieve the required participation. This should be close to the actual number required. If you enter a few or too many analysis, make no longer participation in the RSA, with the specify the participation required with each of the directions isn't achieved with the stopping criteria of the RSA and analysis. It will still be performed by a warning will be issued. Minimum mass participation with RSA. The minimum participation isn't achieved before stopping criteria RSA analysis is not performed. Parameter stopping criteria supersedes both the number of the modes and mass percentage. Jacobi settings, max number of the sweeps. A sweep is a transformation every off-diagonal global matrix of this set with the maximum number of the sweeps. Allow a sweep tolerance each with the sweep value with the check that begins with the previous sweep result. If the difference is left with the tolerance will result with the convergence of the analysis is complete. So space settings, maximum number of the iterations to perform tolerance at the end of the iteration value check that begins with the previous iteration result with the difference less than the tolerance result with the converged analysis is complete. Feast initial search engine specify the initial range of the feast which will serve with the Eugene values n over estimating multiplier with each of the range, especially for the initial guess for the subspace of the dimension to be u with the overestimating the predicted number of modes with the range maximum nodes of the range of the maximum level of the modes with the range of the more of the modes found with the range is split. Smaller ranges. Minimum search range of the range is smaller than no longer be split with it, even if the maximum number of the modes greater than allow. The mode model combination method that will determine the representative of the maximum response for the interest of the load case with the relevant value with the relevant even each of the relevant mode with combined with using the method to specify the now that once modes have been combined with the relative signs are lost. The QCQ suitable method with the must be with the closely spelled or well spaced. SRS suitable only for the amounts with the modes where are well spaced. A modification factor, the different factor that could be applied with a different material to each of the different solver modes in order to adjust the following properties. E for young models, G for shear models, I torsion section inherit with about local X, I major section inherit along local Y, I minor section inherit along local Z area, the section area with the compression and tension, A parallel to minor shear area with local Y, A parallel major shear area with local Z. T, the shell thickness of applicable to the concrete. Only these factors according to the members, and in this case, the concrete members, whether they are cracked or not. Although default modification for each of the material provided setting sets for the reflective design code being worked through the check whether they are appropriate for the particular analysis model. But if you make changes to any of these factors, analysis must be repeated. Concrete slab, flat slab, foundation, mat, beam, and slab modification factors can only be to solve the models in which the slab adopts the shell mesh, so they do not get applied with the solver models where the slab adopts the semi-rigid mesh. Meshing. The parameters that can be adjusted in order to fine-tune with the mesh of the produce the slab at the wall of the default say with the generally appropriate, but they can potentially be adjusted. The 2D element quality errors are being created during validation. Composite steel beams inherit used in the loading analysis allows engineers specify the inherit to be the global analysis model with a composite steel beam default long-term composite short-term composite US head code. When longer and short-term inherit and selected, they only apply with the following section rules: metric I section without web openings. Further, other section standard steel beams inherit with the regardless analysis of the options selected. The ECH head code with long short-term inherit is selected only apply with the following sections: symmetric I rolled section without web openings, I plated sections without web openings, West stock plated sections without web openings, and fab sections without web openings. For all other section standards, beams inherit with its use regardless of the analysis option selected. BSH head code. BS head code, long short term and then selected with only apply with the following sections: symmetric rolled section without web openings, asymmetric I rolled section without web openings, I plated section without web openings, web stock plated section without web openings, fab section without web openings. For all other section standard steel beam inherit with the use of the regardless analysis option. Select the AUS head code with the design composite bit is not currently supported with the Australian head code. IS head code of design composite is not currently supported by the Indian head code. Working with the FE mesh slabs at level of the two-way spanning slab, if the FE mesh is applied as followed. If the level of the option mesh two-way slab of the analysis clear with the slab adds to the level that are only meshed with the order to allow the decomposition to occur with the prior to note. The analysis itself of the slab with the not mesh with its default everything. If the level of the option mesh 2 for the slab analysis selected the load of the decomposition not performing a two-way slab at the level they are meshed in analysis. Two-way spanning slabs are also meshed for the FE chase down that occurs as part of the static design process, and all the above situation the meshes are created according to the defined mesh parameters. How do I specify whether the levels of the mesh slab analysis? FE load decomposition level base setting with the control of the two-way slab is meshed in the building analysis. FE load decomposition is carried out, and instead You can choose the FE mesh slab that cures certain level only with the FE decomposition of the remaining levels if you so required. And to use two-way mesh slabs, building analysis level to highlight the levels of the structural T property windows, mesh two-way slab within 3D analysis, the FE decomposed slab loads to all levels, highlight levels in the structure tree for the property windows, mesh two-way slab with 3D analysis, to mesh two-way slab specifically FE composite slab loads to the other, expand the level of the structural T, click each construction level and in turn select clear of the mesh two-way slabs in 3D analysis. Is required. How do I control the mesh parameters to be used? Mesh parameters are held as property of the structure with the identical same as the mesh of the parameters are applied with globally on all fours. The parameters are specified as follows. Select the structure branch of the structure tree. You will see the structure property in the properties windows. Adjust the shell mesh size and shell uniform factor as required. Although default size is uniform at 3 foot 6 inches at 50% are likely to conservative with the degree of the mesh for free and fast refinement apply the remaining user responsibility to optimize solution time, consider the coarser mesh during the design and development before switching more to refine mesh at final design stage. Different mesh parameters can be applied with a specific floor by introducing additional sub-models. How do I apply different mesh parameters to different levels? If you require different mesh parameters to specific level, you'll first need to introduce additional sub-model at the level. Once the new sub-model has been created, to expand the sub-model branch in the structure team select it. You'll see with the properties and selected model in the properties window. Check the override model box and adjust the shell mesh size to uniformity as required. How do I review the slab mesh prior to the running analysis? Open the solver view, right-click anywhere with the view with the tree with the solve of the model, the context name of the sub, and then you tree with the solve of the moves model appropriate to the analyst to be run, and the slab mesh with the display with the apple with the solve of the model, the slab mesh with the display with the working solve of the solver model. At this show, model and form prior to the analysis to the elements only with the formed at point of the slab mesh groups. To facilitate meshing the slab panel with the feature of the gap together automatically with the mesh group. The mesh single entity of the mesh group cannot be edited directly. The mesh group contains one or more panels identically with the analysis of the attributed since the panel thickness of the key analysis attributed by the definition slab type of the column drop will produce the additional mesh group. The example of the mesh group is a slab step and consider the following three slab panels thickness is shown. So it shows panel 1, panel 2, and panel 3. Panel 1, 100 millimeters, panel 2, 100 millimeters, panel 3, 300 millimeters. Although there are three panels, there are only two slab depths, so the only two mesh groups are required. And it shows, then it shows the mesh group 1, mesh group 2, related discontinued force contours, slab steps, column drops. Discontinued force contours slab steps of the column drop. The consequence of the slab panels of either side of the steps being placed with a different mesh with the group of the solve with the modes with the boundary with the chair with both group with each of the node with the boundary reports a single value of the deflection by two values of the force, one of each for the group that hinge with the discontinued force contours along with the boundary. Deflection contours no discontinuity. Shows moment contours discontinued along boundary. And then it shows a selecting any solver node 16 forces at panel 2. And for force discontinued with a genuine result, slabs share the same curvature of the step that have the same elastic modulus and some of the moment bumps in the direction proportional with the area of each panel. Other programs may choose the average value of the cross of the boundary with generating the contours approach the adaptive of the Tekla structural design preferred since every way averaging would result with the unrealistic high design with a thinner slab. Mesh group with the boundary warnings. Mesh may fail to produce undesirable result with a challenging mesh group of the boundary geometry, in which case the points or the source of the meshing issue that are provided. For example, the possible warning triggers are short edge, the distance between hole and edge, small area closed by mesh group. Working with the FE mesh wall by default, unless the edited with the mid-pier model with the concrete wall, the top of the FE mesh model with the building analysis of the mesh wall with the default of the model mesh parameters, they can be overridden and all with the U of the defined mesh applied with the individual wall. How to control the global wall mesh parameters to be used. The mesh parameters are held with the property of the structure of the initial same with the mesh of the parameters applied with the globally all mesh walls. Parameters specified as follows. Select the structure branch for the structure tree of the build structure property windows. Use the wall mesh type of the type property control of the shell shape of the mesh applied. Use to specify the wall mesh of the type of the quad only quad dominant. Adjust the wall mesh horizontal only size and wall mesh vertical size is required. How I override global wall mesh parameters for an individual wall. If you require different wall mesh parameters, apply with specific walls to achieve the editing wall property. Select the walls to be edited with the property window, the wall mesh type of the property to control the shape of the mesh. Apply with the depth of the wall mesh horizontal side, wall mesh vertical size is required. How do I require the wall mesh prior to running it else? Open solver view, right click it anywhere with the view of the solver method, the context menu with the sub menu, choose the solver mount appropriate to the analysis to be run. The wall mesh method displayed with the applicable solve of the model selected. The wall mesh is not displayed in working solve of the model as if it shows the model of the firm prior to the analysis of 2D elements only of the formed and point analysis. Working with rigid and semi-rigid diaphragms. The diaphragms are formed with every slab panel with a parent slab with a diaphragm option with a slab property of the rigid or semi-rigid of the rigid diaphragm. So for the nodal constraints, they automatically apply to the associated slab nodes. With a semi-rigid diaphragm and a mesh semi-rigid 2D element is created within the slab. How to activate rigid diaphragm in action with a slab? My default slab with the created with a rigid diaphragm own percent already set, but you can remove the edit of the setting with a specific slab. It's filed from slab branch of the structure T with the slab which contained with the diaphragm with the property win with the diaphragm option is required. The setting of the diaphragm option property to slab item have the same effect with the property of the parent slab, but either way, slab item slab adopt to the new diaphragm option setting. How do I affect with the semi-rigid diaphragm action within a slab? Semi-rigid diaphragms that can be formed by both one or two ways spanning the slab. The property can be reviewed with the editing selecting slab with which can be obtained with the slab range for the structure T. Select the slab with the property win with the diaphragm option. The slab semi-rigid with the required with the divided stiffness. You show the flexibility with the diaphragm and the mesh parameter with the adaptive with the semi-rigid. The diaphragm's control with the structural property to display with the structural branch into the structural tree. Setting of the diaphragm option property to slab item for that have same effect with the property of the parent slab. Either way, slab item slab at the top of the new diaphragm option setting. How do I identify with which of the nodes constrained with the rigid diaphragms? In order to see with the nodes with constrained with the diaphragms, you must first open the solver view. In the solver view, rigid and semi-rigid diaphragms are presented with a different color and shaded planes. No diaphragm, semi-rigid diaphragm, and rigid diaphragm. NC for the non-constrained, T for constrained, E for excluded. Nodes constrained with a rigid diaphragm can be identified with the first one must lie within the edge of the tree with a rigid diaphragm. Second, with them must be excluded with the nodes if they should be solid rather than hollow. Flowing therefore in the non-constrained with a rigid diaphragm, solid nodes for the list outside of the tree, the rigid for the diaphragm plane, and exclude with the hollow nodes. How do I initially exclude with the individual nodes with a rigid diaphragm? In order to exclude with a specific node with a rigid diaphragm, you first open the review view. Click review with the diaphragm on and off. The nodes of the display is travel. Include the nodes that they're only constrained with the lie within the edge of the bridge of the diaphragm, the outside of the rigid diaphragm, not constrained, and exclude the nodes. They are always unconstrained. 4. Click the node with the toggle state with between include and exclude. How do I initially exclude with the slab panel for the diaphragm? By diaphragm, rigid panel with a diaphragm in the form of an individual slab panel with a slab. However, that possible to indicate the slab specific slab panel should be excluded. It's filed with the structural view of the slab panel to be excluded. The property windows include with the diaphragm. Individual slab panels can exclude with the graphically diaphragm on off command. Review view. Clicking on slab panels and toggles and inclusion diaphragm. Running analysis. How to run a first order linear or nonlinear analysis. How to run the first order linear analysis. Click Analyze First Order Linear, select the loading dialog, choose the combination load case of the analyze, then click OK, and the analysis active view, switch with the result view with the tab of the switch for the analysis with the result of the reading, ready for reviewing the result graphically. How to run a first order nonlinear analysis. Click Analyze option with the gear with the review of the first order nonlinear convergency criteria with adjustments required. Click Analyzing First Order Nonlinear, select loading dialog, choose the combination load case for the analyze, click OK. At the end of the analysis, activate the view switch of the result view within the tab of the switch of the analyze to the result, ready for reviewing with the result with graphically. How to run a two-ordered linear or nonlinear analysis. How to run a two-ordered linear analysis. Click Analyze second order linear of the selecting loading dialog with the combination load case and analyze, then click OK. The end of the analysis process with the active view, switch result view with the active tab of the switch of the result with the ready for reviewing the result graphically. How do I run a second order nonlinear analysis? Analyze like an option, review the second order nonlinear convergence and criteria with adjustments required. Check analyzing second order nonlinear, selecting loading dialog, choose the combination load case and analyze, click OK. At the end of the analysis, properly active view of the result view, and then activate the switch result with the ready review and the result graphically. How to run a first order vibration analysis. Know the analysis of the required with the vibration mass combination, the analyze option with the review of the first order vibration analysis option, add just as required. Click analyzing first order vibration, end of the analysis process, active view switch of the result view with the active view switch of the result with the ready for the reviewing result graphically. How do I run a second order buckling analysis, analyzing option, review the second order buckling options, adjust if the required. Click 2. Click on analyzing second order buckling. 3. And select the loading dialog box. Choose the combination load space. Case of the analyze, click OK. At the end of the analyzing process, active view switch to the result view with the active tab switch for the result with the ready for viewing result graphically. How do I run the first order and second order seismic analysis? I run the first order RSA seismic analysis. Click analyzing option. Review the first order seismic analysis option with the F that's required. Analyze first order RSA seismic and add to the analyzing process. Activate the switch for the result view with the activate the switch for the result with the ready for viewing the result with the graphically. How do we run the second order RSA seismic analysis analyzing option with the check with the seismic analysis option adjusted if required. Check analysis second order RSA seismic at the end of the analysis process with the active view switch for the result view with the active tab switch for the result with the ready for viewing the result graphically. How do we run the FE chase down with the grill chase down analysis? These analyses are run in addition with the first and second order 3D analysis by selecting analyzing all static. They also run when required as part of the combined analysis of the design process. Grill chase down analysis perform one of the more concrete members exists. FE chase down analysis perform on two-way slabs or by user option with the design options dialog having an option to design concrete beam columns or wall of the FE chase down results. Both of these analyses are run for load cases only and not for combinations. How do I run an analysis all static? Check analyzing analyze all static with all analyzers required to enable the static design perform all load case combinations. 3D analysis either first or second order specified for the design option analysis. Grid chase down if one or more concrete members exist. FE chase down with two-way slabs exist by user option. At the end of the above the analysis, active view switch with the review the tab switch analysis the review ready for individual members should be checked and designed. Graphical display in the solver mode and solver view. Solver model for use for each of the analysis to be viewed in second in 2D or 3D from the appropriate solver view. The following entity is not part of the solver model with the grid construct for the lines of the dimension slab openings, one wall, roof panels. Consequently, they are never displayed in the solver view. Conversely, with the diaphragms exist in the solver model, they are only displayed in solver model, not displayed in the other view types. How do I open and solve the view? To open solve the view in a new view with duplicating second and third view, duplicating existing 2D or 3D view with the right click of the tab, the duplicate view with the right click menu. Change the view type newly open the duplicate view with either right click with the tab or the select with the solver view with the right click menu or by right clicking or clicking solver view button on the status bar. With the change with the existing view with the solver view, select the appropriate existing 2D or 3D view, change with the view type with the view with either by right clicking on the tab with the selecting the solver view from the right click menu or by clicking solver view button on the status bar. How do we display the solver model view with a particular analysis type? Open solver view, right click anywhere with the view, the choose with the solver model with the context menu, the sub menu choose with the solver model required. How do I see with the solver node of the solver element properties for the open solver view to display so appropriate solver view, select with the node element required, select with the node elements property for the display with the property windows, tabulature data, solver model data. Solver model data view with the provide with the tabulature means with the view and the rail analysis data can insert with the result of the different analysis type of the have and perform tabulature data display with the node element of data with the have the view with the tabulator with the coordinates degree of the freedom. Quick analyzing tabular data, solve with the model data view with opens a new tab for the view type of the drop list, choose nodes. How do I view a tabulated solver element? Properties 1, analyze tabular data, solver model data view with the opens in the new tab, check from the view type drop down list, check the elements, tabular display reaction, deflection, and forces. How do I view the tabular results, support reactions? Quick analyze tabular data, solve with the model data view, open with a new tab for the result type, drop list, check for the analyst type, support reaction that can be viewed with the analyst type of the part for the first order vibration, second order buckling. From the view type drop down list and audio forces, look at the load case combination envelope required for the load drop listing. How do I view the tabulature result of the model deflections? Quick analyzing tabular data, solve the model data view with the open the new tab for the result type of the drop list for the analyzing type non-deflections can be viewed the analyzing type over the first order and vibration, second order buckling. Alright, 3. For the view type of the drop-down list, the deflection load case combination, the event envelope required for the loading drop-down, if the combination of the swing with the result type of the drop list, with the chose with the between the strength of the factor, server this factor, with the how do I view, tabular result with the solver element and force. Click analyzing the tabular data, solve the model data view with the open a new tab with the result of the drop list view with the analyst type of the element and forth with the computer view with the analyst type of the power with the first order with the vibration, second order buckling from the view type of the drop list. Choose the element and forth with the select the load case combination envelope required for the load listing, drop the result of the drop list play with the raw analysis result of the element and forth with the result of the habit and the annexal load reductions applied. Where does the asterisk next to the certain over the signifying the element and end force table to display with the table of the element force with the moderable ridge arms. Then you may seek the asterisk with the again for the start end over the certain element the numbers of the node number of the asterisk with the next to with the signify with the result of the actually output of the end of the ridge arm rather than the node itself. How do I view tabular results from wall lines? Click Analyzing Tabular Data. Show the model data value opens with a new tab. Click the result type. Drop list true with the analyzing type. Wall line force can be viewed with the analyst type of the part with the first order of the vibration, second order buckling. From the view type of the drop list of the wall lines. Select the load case combination envelope required for the load drop. Listing, tabular display, vibration, buckling, analysis report. How do they view the tabular result of the mode shape? Click on Analyzing Tabular Data. Solve the model data view. Opens the new tab. Select from the result tab. Drop list true for the analyst type. Model shapes can be only viewed with the first order vibration, second order buckling, analyst type. From the view type, drop list true for the mode shape. Select the load required for the loading drop list. How do I view the sum mass of the vibration mass combination? Click Analyzing Tabular Data. Solve the model data view with open a new tab of the result type. From the result type, drop list of the first order vibration analyst type of the view type of the drop list is sum mass. How do I view the dynamic mass of the vibration combination? Click Analyzing Tabular Data. Solve the model data view. Opens a new tab of the result from a result type. Drop list. Show first order vibration analysis type. From the view type, drop list. Show the dynamic mass. How do you view the active mass of the node? Click Analyzing Tabular Data. Solve the model data view. Open a new tab. First result type. The drop list. First order vibration analyst type. From the view type, drop list for the active mass of the node. How do I view the total mass of the node? Click Analyzing Tabular Data. Solve the model data view. Open a new tab with the result of the drop list for the first order vibration analyst type of the view type of the drop list for the total mass node. How do I view the vibration frequency model math? Click Analyzing Tabular Data. Solve the model data view. Open the new tab of the result of the drop list for the first order vibration analyst type of the view type of the drop list vibration frequency. Select the load combination required for the load drop down list. How do I view the buckling factors? Analyzing Tabular Data. Solve the model data view. Open the new tab from the result type the drop list. The second order buckling analyst type of the view type of the drop list of the buckling factor. Load case combination required for the load drop down list. Graphical display of the analyst result of the result view. Once you have the defined the analyzing model, you can review the result with the analysis graphically. 2D or 3D result views using the results toolbar, and result type group. The result type group contains two drop lists and two buttons and descriptions. Analyst type the first drop list for the analyst type of the drop list true for the analyst type of the display with the result of the first order linear, first order nonlinear, second order linear, second order nonlinear, first order vibration, second order buckling, FE chase down, grill chase down node. Mode 2, second drop list. Analyst type the set with the first order vibration, second order buckling, and appropriate load case combination. Selected the load drop list mode. Drop list becomes active. It was used to select the vibration mode, which results are to be displayed as reduced axial force display with a click and a button with the reduce the values only applies to impose the load cases which have been defined with the reduction applied with the divinity with the combination include with the same load case. SLS deflections display for the combination. Click with this button with the display with the serviceability opposed with the strength of the load of the factors. Scale setting group the button in the description. First 1D force scale with the slider with the increase with the degree with the diagram scale with the 1D force. 2D force with the slider increase with the degree with the diagram scale with the 2D force. Deflection scale with the slider increase the degree with the diagram scale with the deflection result. 1D result group with click of the control with the display analyst with the result of the 1D element beam column thrust etc. with the wall beam sponge with the mid-tier option as of the following the category 1D result. Click at the bottom to activate the display with the required 1D result true within the drop list below with the 1D result with the drop list with the 1D drop list with the true with the result type of the display. Axial force on the local X, shear major with the along local Z, shear minor along local Y, torsion along local X, moment major bending on local Y, moment minor bending on local Z, moment biaxial bending on local Y and Z with a deflection group of the click of these control with the display with the deflection result with the 1D member of the beam with the columns, etc. Walls mounted U with the mid-pier options also fall in this category. Whole structure of absolute global deflections are shown on the relatively underformed model. Button and description. Deflections. Unclick at this button to activate the display with the required deflection result true with the drop-down list below. Deflection drop-down list. The first 1D drop-down list true for the result of the type of the display. X model of deflection with the global X. Y model of deflection with the global Y. Z model of deflection with the global Z. DR1 or direction 1 model of deflection with the building direction 1. DR2 the model of deflection with the model of direction 2 with the total of the result and the model of deflections. Rotational horizontal forces. EHF the display with the calculated equivalent horizontal force selected with the combination. Seismic the display with the calculated equivalent lateral force. The torsion selected load case and combination. 2D result group with a click of these control of the FE with a contour with the two-dimensional elements of FE slab and the FE wall with a contour of the always panel with the axis system based on shear shell nodal forces. 2D results. Click the button. 2D result. Click this button to activate the display with the required with the 2D result shown on the drop-down list. 2D resolve of the droplet for the 2D droplet, resolve of the droplet tube of the resolve of the type of the FX of the axial force of the x-axis, FY axial forces panel X for the FXY, complementary plane shear of the FXZ, shear panel of Z-axis of the plane XZ plane, YZ shear plane of Z-axis panel YZ plane, MX bending along the panel X, MY bending along the panel Y, MXY plate torsional moment, MDX top of the wood armor top bending along with the panel X, MDXB bottom, wooden armor bottom bending along the panel X's, MDY top and wood armor top bending along panel Y axis, MDY bottom wood armor bending along panel Y axis bearing pressure. The as required group. Click over the control of the FE, control of the two-dimensional, all of the FE slab and the FE wall, the node of the contours always in the panel X system based on the shell and non-dual forces. But as required, click over the button and activate the display with the as required with the show of the first drop list below. As required first drop list, as required drop list true for the result of the type of display with the X top of the required steel area of the contour of the top face of the slab along with the panel X. X bottom required steel area contour of the bottom face of the slab along panel X. Y top of the required steel panel contour over the top of the face of the long slab along panel X. Y bottom required steel area contours of the bottom face of the slab along the panel Y axis. As required second dot down list, either the choice of the way to display the value with pass and fail state with the result of the type of the list of the first draft of the value of the contour display value with the pass and fail threshold with the contour of the display with the 2D deflection group of the list of the contour. Click these controls of the FE deflection contours of the two-dimensional envelope and the FE slab and the FE wall for the whole structure of the global deflection shown with the relatively undeformed model. The button in description, 2D deflection, click this button to activate the display with the required 2D deflection result chosen from the drop-down list. 2D deflection drop-down list. First 1D result drop list of the result of the displayed X 2D element of deflection global X, Y 2D element of deflection global Y, Z 2D element deflection global Z, total with the total resolute 2D element of deflections. 2D strip result control group. After create a strip of the companion with a 2D view of the define the strip, click the 2D strip of the result of the top and the 2 with the result of the drop list that's displayed along the strip of the best was displayed in 3D view. Create the strip, the button, create the strip to play for the strip to draw for the mesh of the result of the strip to maybe display with the view of the design purpose to create the strip only with the 2D view is active the 2D result, 2D strip to result. Click the button and activate the display with the required 2D strip to result the chosen from the drop down list below. 2D strip of the result of the drop list, shoe with the result type of the deflection, display with the deflection diagram along with the strip, shoe with the display with the shear force diagram along with the strip, moment of display with the moment of diagram along with the strip of the design, moment of display with the design, moment of the diagram along with the strip, the as required to display with the area of steel required the diagram along the strip. 2D wall result group. FE walls result in the collated with the display with the result lines created with the automatic with the FE wall, the result of the display with the similar with the 1D result with the mid-pier walls, the 2D wall result button. Click the button to activate the display with the required 2D walls the result chosen from the drop-down list. 2D wall result. Use the drop list true for the result type of the display with the axial force. The display with the axial force diagram along the result line. Shear made to the display with the shear force matrix diagram along with the result line. Shear minor display with the shear force matrix diagram along the result line. Torsion display with the torsion diagram along the result line. Moment of major display the moment major diagram along the result line. Moment of minor display the moment of minor down along around the result line. Or a text group. They click these control the display with the numeric value of the diagram, select the result of the button in description, deflection of the display with the deflection value with the deflection diagram, the actual force display the actual force value with the actual force diagram, shear display on the shear value with the shear force with the diaphragm, support reaction display with the reaction value with the support reaction beam and the end reaction diagram, torsion display with the torsion value with the torsion diagrams, and moment of display with the moment value with the moment diagrams. Cross-checking the sum of the reaction against the load input with the once for the analysis of that has been performed with the loading trend can be used with a quickly check for the total reaction for each of the elements for the weight for the total load of the structure. This allows you quickly to assess the number of the applied load that has gone in missing. To assess each of the load K for the combination indicate its valve with the check of the total reaction equilibrium total load of structure. X if the total reaction is not equal to the total load of structure. Question mark if the total reaction is not available. Load case is property when you select the load case for the loading tree with the following properties displayed with the property windows. General section provides summations global X, Y, and Z. The different load type is applied for the structure of these total will apply the load to determine determine the total reaction 3D analysis result is reported, property, and description. Member loads, the property, sum of the loads applied with the head of the member loads of the structure. Now loads, property, the sum of the loads applied with the now loads to the structure. Total NFH direction 1, sum of the NFH direction 1. Total NFH direction 1, sum of the NFH direction 2. Decomposed load, decomposable loads, property, sum of all of the loads applied with the panel loads for the structure prior to loading. Decomposition, one way of the decomposition results. After loading decomposition, some of the load of the decomposed with the members of the one-way spanning result. The two-way the decomposition results after loading decomposition, the sum of the load of the decomposed and the members of the two-way spanning panels. Total user applied load, some of all of the loads applied with the structure prior to load decomposition to load on the structure. Some of the one-way, two-way decomposition results. Total reaction, some of the reaction of 3D analysis. The report with the total user applied load should be compared with the total load on structure. The report with the total load on structure should also be checked against total reaction. FE chase down with the total reaction overall. Some of the description with the FE chase down analysis. Each of the submodel load above, some of the vertical load applied with the submodel from the submodel directly above it. Load applied, some of the vertical load applied on the submodel reaction, some of the reaction of the analysis of the FE submodel with the total user applied from the general section should be cross-checked against the total reaction addition of the submodel. No, I'm good. Yeah. In addition, for each submodel with the load applied with the load above it should equate with the reaction property, total reaction overall, some of the reaction of the grill chase down with analysis. Each submodel load from above, some of the vertical load applied with the submodel from the submodel directly above it. Load from applied, some of the vertical load applied with the submodel reaction, some of the reaction analysis for the grill, the submodel with the total use applied with the general section cross-check again for the total reaction. In addition, each for the submodel load applied when it added the load from and above the show the equate with the reaction display with the 1 and 2 degree result deflection reaction. The 1 to the analysis type of the load of the load case of the combination the envelope has been shown for the result that can be displayed simply by selecting the required effort for the appropriate group of the result ribbon. 1D group show for the 1D elements, beams, column, the truss, etc. Also for the walls model with the U of the mid-pier option. The 2D result show for the result of the elements, FE slabs, and FE walls. How do I achieve the analysis of the results for when we serve the analysis type of the have been performed the results of each of the help of the separately, but there is no need to re-perform the particular analysis to recall the results. Select the analysis for the type of the required with the drop list result, the type of the group of the result tab, select the diaphragm to display the analysis type required, how I achieve the load case combination envelope to see the result for. With the first click of the load case combination envelope button, the load drop down list, and select and show the load case combination and envelope, and drop-down list. Let's look at the specified load case envelope required from the drop-down list. How the display support with the reaction. 1. Select the analysis type of the required with the drop list result, the type of the group of the result tab. 2. Select the load combination of the display with the load drop-down list. 3. From the reaction group of the 2 for the support reactions, and 2 for the reaction required with the drop-down list. From the text group, the 2 for the reaction. First, how do I display the 1D results and 1D for deflections? So for the analysis of the required with the drop list for the result type group of the result tab. Select the load case for the combination display with the loading drop list for the U. The first 1D result of the 1D result group, the 1D result then group the drop list under the each two of the results required. To view the first 1D deflection of the deflection group of the deflection have the drop list underneath the trove of the deflection required. To show the value of the diaphragm of the text group and show the effects required. How do I display the 2D result of the 2D deflection? Select analysis type of the required with the drop list result type group of the result tab. So the load case of the combination display of the load drop list. For the 2D the 2D result from the 2D result group of the 2D result from the drop list underneath the two of the result required. To the 2 2D deflection from the 2D deflection quickly group, click the 2D deflection from the drop list underneath the tube of the deflection required. How to display as required contours. As required contours can either display its values or pass-fail threshold. Displaying a pass-fail threshold helps to visualize minimum patch sizes, optimizing panel and patch reinforcement, highlight specific area of the existing reinforcement not sufficient. Selecting the analysis type of the required with the drop list result type of the group of the result tab. Select the load case combination display with the load drop list for the as required group of the issue of the effect with which will display with the first drop list. To view it as required contours as values from the second drop list as required group, choose value. View the as required contours as values for second drop list as required group, choose pass or fail. What are the 2D wall results? How do I display them? By processing the FE mesh for the wall nodule analysis result, it is possible to determine the 4 of the moments of the as result lines that automatically created within the walls. These results can then be the design purpose design convention of the result lines output falls for the mid-pier wall with the model of the 2 view of the 2D walls. The result of the open 3D view containing the walls of the U with the select of the analysis type of the required with the drop list result type of the group of the result tab. Select the load combination display with the load drop listing from the 2D wall results group of the 2D wall result from the drop list underneath the true with the result of the required Tekla structure of the design and display with the chosen effect of the result line. How to increase the amplitude of the diaphragm, force and deflection, slayer setting panes for the adjust of the diaphragm, minimum amplitude, maximum amplitude, first digit 1D, 2D forces 1D, 2D forces minimum amplitude. How do I see 3D display with the result of the 2D view with because of the diagrams reply with each of the planes in which they act. We're working in a 2D view when they need to switch to isometric display of the see out of the plane. Force the 2D frame. The 2D frame with the display isometrically. 2D view is currently displayed with the 3D toggle with the button status for the bar with the bottom of the right screen when it will be labeled 3D. Click the 3D 2D toggle button. 2D view the down displays isometrically. The 3D toggle button chain with the 2D changes back to the plan. 3D to 2D toggle button once more. How do I customize with the display with the 2D contours? View the default all contours comprised with the 10 is evenly sized contours. Each of the count with a 10% for the total range. With the degree for the number of contours, also change the size of the color, individual contours side. Click home settings, activate settings of the display with setting sets for the page in order to change the contour configuration. Current working session of this setting should be edited. Expand scene page of the contours. Click space for the end of the new contours. Delete to remove contours. Each edit size for each of the contours required. Also change the color of each contour. Revert default configuration. Click reset display mode shape. Mode shapes can be displayed with the first order vibration, second order buckling, first order RSA seismic, and second order RSMA seismic analysis. How to display with the model shape of the several analysis have to be performed over each one is held separately. There is no need to perform a particular analysis to recall the result. On result ribbon, select the analysis type of the either first order vibration, second order buckling, first order RSA seismic, or second order RSA seismic. The drop list of the result type group. Select the load case combination required for the load drop down list. RSA seismic analysis only load case should be selected in any of the modes and not applicable to the combination, hence cannot be viewed. Select the mode required for the mode drop list of the result type group of the diaphragm to display notational forces, seismic equivalent lateral forces EHF, equivalent horizontal forces applicable to the Euro code, the magnitude of the equivalent horizontal force, particular combination, selection of the combination required for the loading, drop down list on the result of the ribbon, click the EHF of the nominal in the notational horizontal force group, notational loads, applicable to the United States, ACI, AISC, only the magnitude of the notational load of the particular combination, select the required combination, include with the notational load loading, dropping list on the ribbon, result ribbon, click the NL notational horizontal group, NHF, applicable to BS Australian codes only, the C with the NHF of the particular with the combination, select the combination required with the load drop-down list result of the NHF of the notational horizontal force group with the seismic. C with the magnitude equivalent lateral force of seismic load combination. C with the required seismic load combination of the loading drop-down list result with the ribbon and seismic notational horizontal force group display RSA seismic result. The result type of the first order, second order RSA seismic. The result that can be displayed depending on the type of currently selected load case and combination model shape that have the display of the RSA seismic load combined or CQC or combined SRSS, depending on the choice of the analysis option, plus all relevant mode locates effective with the seismic wave of the combination list. All of the modes return with the vibration analysis. The mode shape did not display with the RSA transitional load with the selected static loads include the RSA seismic combination first 1D element result of the I1D element result displayed as probably the RSA seismic loads combined CQC and combined SRSS, depending on the your choice of the analysis option. The absolute value determine the various points of along each member, and then plotting both positive and negative of the diagram. Such of the diaphragm is always symmetrically about the baseline. All relevant modes in standard envelope. The diaphragm is displayed with the RSA torsional loads displayed in perv for the first order of linear analysis. Static loads include the RSA with the shear with the combination displayed in the perv first order linear analysis. Effective seismic weight combination not available. The RSA seismic combinations and envelope drawn to show the seismic result above and below the static result baseline with the 3 of the static view. The top line static view positive, the seismic value. The bottom line is static view with a negative seismic value. Show the static result value X value S static seismic values and top seismic result. Final combination results. Storage shears. Storage shears is displayed as the following: RSI seismic load cases combined with CQC combined with SRS, depending on the choice of the analysis option of the absolute value with the determinant in each of the position of interest. Result with it shown in the both positive and negative. All relevant modes in standard diagram of the single value of the points of the display of the RSA torsional located with the display of the per first order with linear analysis. Static load case is included RSA seismic combination display in the per first order linear effect analysis effect with seismic weight combination not available. The RSA seismic combination of the diaphragm to display the two values each of the point enter the static value plus positive seismic value, positive static value, negative seismic value. Alright, that shows your support reactions are displayed with the RSA seismic load case of combined CQC or combined SRSS. Bringing on the choice of the analysis option, absolutely determine each of the report results shown in the both the positive and negative all relevant mode standard diagram display the RSA torsional load case standard diagram display the static load case include RSA seismic combination standard diagram is displayed effective seismic weight combination not available. The RSA seismic combinations diaphragm display with each of the static value, positive seismic value, static value, negative seismic value. 2D wall results. 2D wall results are displayed as well with the RSI seismic load cases combined CQC combined SRSS depending on your choice of the analysis option. Absolute value with determinants of the points along the wall line of the plotted both the positive and negative side of the diaphragm. The diaphragms are always symmetrical about the wall line. All relevant mode standard diagram and the view of the RSA torsional load case standard diagram is load displayed with the static load case included with the RSA seismic combination standard diagram is displayed. Effective seismic weight combination is not available. The RSA seismic combination envelope drawing shown with the seismic result above the below the static result baseline through the static value of the line above the static positive value, seismic value, line below the static negative seismic values, and so the result of the baseline. So, working with the 2D strip, the displaying of the strips, result of the strip, the overview of the view, the time of the result, strip that can be placed across the 2D element fresh. Measure these strips the force of the moment of the result determine the shell plate with the membrane with the nodal angles. Result of these can also be with the design purpose, typically for slab design, engineering judgment of the position of the strip of the distance. Ensure suitable design force and obtain with the default of the parallel edges tapering strip that can be defined as shown below. So, to start with the column typical of the position and width of how to occur the result strip, you must first open the 2D with the FE mesh with the strip that is to be placed, then display with the result tab. To display with the result tab in stats bar, click result view to create the strip. To display with the result, create strip with the result, strip with the properties, display with the property windows, adjust the properties, set the specify the start and width of the strip with the result type, the average center line, maximum, the number of the station of the parameter along the strip, the number of points of the meter across the strip to each station. 3, click on point with the strip to start. 2, click the second point with the strip to end. Neither start or end points have to match. Neither the start or end points have to match nodes in the mesh. Typical structural design, create the strip the points of the identified. Either continue to place further strips if done exit to exit. How do I delete a result of the strip? The delete of the strip, the first ensure the result strips are the switch for the scene content. Open the view containing the strips to be deleted. Click delete. Click the strip and to be deleted. How do you view the result of the result strip? The result strip of the habit defined with the model. You can obtain the result without having to rerun with the analysis. Provide an analysis habit then run previously. Open the 3D view containing the strip to review with the trick the analysis type to require with the drop list for result type with the group of the result type. So for the load case combination you will want to show display should be selected with the load drop down list from the 2D strip of the group of the result tab. The true the effect that you want to display. Tekla structural display. Designer will do is display with the chosen effect of the strip along with the maximum positive and negative value calculated in accordance with the method specified for the strip properties. Our strip results calculated along with the strip center, they are defined with a number of stations. Each station have the transverse line with a user-defined number of the points along with the final result with the always given and safe to obtain with the may or may not use the points. There are 3 alternative ways to calculate the result. Normal, the result of the center with the result strip calculated each of the station shell elements local each of the station consider the weighted average force for the calculated base for the distance element nodes from the shape of the repeated for all stations along the center line of the strip given the result of the strip of the maximum result of the transverse line across the strip calculated to effort each of the strength station along the strip of the shell elements locate local each with the point with the strip of the weighted average force for the calculated base of the distance element nodes from the point with the maximum result across the strip from the points of the test taken with the result of the station on the strip of the center line of the node the maximum value with include with the nodes with the strip of the values calculated with the point with the always weighted average result of the adjacent node with the hence they are always at the peak nodule values. The repeated for all station center line with the strip give the result of the strip the average over the strip of the result of the obtained in the same way the maximum over the case for the average of give the result of each of the station. This is repeated all stations along the center line of the strip give the result of the strip the all forces of the result of the rotated with the axis result of the result strip. Display analysis result of the individual members loading analysis view the loading analysis toolbar view the view of the load analysis result of the diagram individual members activated right click on the members selecting open loaded analysis view with those contact with the menu with the display loading analysis toolbar contains the following commands. Refreshing load if any change is made with the structure of the loading view the remain open with the must click the refreshing loading in order to update of the display accordingly. Result, drop list, the drop list view of the elements type with the result of the display. Axle of the view, the element loading and result of the axle torsion. Major of the view, the element loading and result of the major axis. Minor view, the element loading and result of the minor axis. Next move of the cursor, the next is over the results along the menu element. Previous move of the cursor to the previous thread of the results along the element. How do I open a load analysis view? Right click the member that you want to view. Select the open a load analysis view with the context menu of the display. Select the load case combination you want to display with the load dropping list. Select the analyst type that you want to see with the result type drop down list with the ribbon. If displaying result of the load combination, select with the view of the results based on the strength and surface factor. Select for the axle type of the axle, major and minor of the direction group of the ribbon, and the result of the display with accordingly can then further control by the property window of the displaying with the RSA seismic result of the loading analysis view. Loading analysis view, first and second order RSA seismic result types, the same rules of the apply with the multi-member with the result view with the same result types as follow with the RSA seismic load case combined CQC or combined SRSS, depending on the choice of the analyst option, absolute value determining the various points of all along each member, then plotted on both positive and negative side of the diaphragm, and the diaphragms are always symmetrical about the baseline. All relevant modes center end of the lobe diaphragm is displayed. RSA torsional locate for the display first order linear axis analysis. Static load case RSA seismic combination play per first order. Effective seismic weight combination not available. The RSA seismic combination drop list provided with the allow with the view with the design profile. The derived with the static seismic result of the design profile is also applied with the stream side with the baseline with the static only result. Static option of the display of the first order linear analysis seismic option only. Absolute value determine various points along with the members of the then applied with the poles positive and negative side of the diagram. Static plus seismic and envelope drawn with the seismic result of the below and below the static result. Baseline through the static value. Top line for the static plus seismic values, and bottom line static value minus seismic value. And then we move it into static static only, seismic only, static plus seismic only, design profile, loading analysis view, property column with the property display with the property windows vary depending on the element, the type of the view with the column with the property, just follow with the property and description, general the distance along with the member to which for the results displayed. Show that a paper with a triangle on it, the concrete column with a rigid zone, have it applied with the only non-rigid length for the column that displayed loading analysis view, stack with the specify the stack with the result of the display, the axle force above the axle force commonly and immediately with above the cross section of the displayed distance specified the properties only displayed by the axle direction, selected by the axle forces below the axle force column immediately below the cross section of the distance specified by the properties only displayed by the axle direction selected, axle force reduced above the axle force column and immediately above the cross section of the distance specified by taking into account with the imposed load reduction of the properties only displayed by the axle direction selected, axle force reduced below axle force of the column immediately below the cross section of the distance specified by taking into account with the imposed load reduction of the properties only displayed by the axle direction selection of the torsional movement above the torsional column and immediately above the cross section of the distance specified by the properties only displayed by the axle direction selected the torsional moment below torsional over the column and immediately below the cross section of the distance specified by the properties only displayed by the axle direction selected shear above the major minor shear forces immediately above the cross section of the distance specified. This property is only displayed by the major and minor direction specified. Shear below with the major and minor shear forces immediately below with the cross section of the distance specified by the properties only when displayed with major and minor direction selected. Moment above the major and minor moment immediately above the cross section of the distance specified by the properties only displayed with the major and minor direction selected. Moment below with the major and minor moment immediately below with the cross section of the distance specified by the properties only displayed the major and minor direction selected. ECC movement the major and minor eccentric immediately above the cross section of the distance specified by the properties only displayed the major and minor direction selected. And the eccentric moment below with the major and minor movement due to the eccentric immediately below with the cross section distance specified property that only displayed with the major and minor direction selected relative to the deflection major minor distance to the specified properties only display the major minor deflection and direction selected. Load above the applied but distributed relate the major and minor direction and immediately above the cross section distance specified. Once again, the property is only displayed minor and major direction selected. Load below the applied distributed load the major minor deflection immediately below the cross section distance specified. The property only display the major minor deflection is selected. The force applied with the point of load the major minor direction of the distance specified. The property only with the major minor direction selection. Moment the applied moment in major minor direction of the distance specified. The property only display with the major minor direction selected. Show axle forces cleared. Axle forces diagram referred from the view. The properties only display the axle direction is selected. Show axle force reduce. If clear of the axle force diagram is removed with the view of the properties only displayed with the axle direction. Selected short torsion moment. If clear of the torsion diagram, remove with the view of the properties only displayed with the axle the torsion direction is selected. Show loading in the clear of the loading diagram, remove with the view of the properties only displayed. Major and minor direction selected. Show shear of the clear of the shear diagram, removed from the direction of the properties only with the major and minor direction selected. Show moment. If clear, the moment of the diagram removed from this property with only display with a major and minor direction selected. Show dimension. If clear, the dimensions are removed from the view of the properties only display with the axle direction selected. Show extreme. If clear, the maximum and the minimum values are removed from the view. Loading analysis. View property with the beam. The property display with the property window depending on the element, the type of the beam. View with the result type of the beam with the property different from the result of the types as follows. Result type axle property and description. Distance. The distance along the member with the result of the display for concrete beams only the rigid zone have been applied with no rigid length of the beam that is displayed with the load analysis view. Your property span. The description specify the span with the result will display. Axle force to the left, axle force beam, and immediately to the left of the cross section of the distance specified. Axle force to the right, axle force of the beam, and immediately to the right of the cross section of the distance specified. Torsion moment of the left, torsion beam, and immediately left of the cross section of the distance specified. The torsion moment of the right of the torsion beam, and immediately to the right cross section of the distance specified. Relative to the angle of the twist. Relative to the angle of the twist due to the torsion beam cross section of the distance specified. Angle of the twist derivative of the dropless for the section of the derivative angle of the twist of first, second, third, property displayed on open sections only along the twist of the derivative left and relative to the angle of the twist due to the torsion beam cross section immediately to the left of the distance specified of the property displayed open section only. Angle of the twist of the derivative of the right angle of the twist due to the torsion beam cross immediately with the right of the distance specified of the property displayed with the open section only. Show axle force the clear of the axle force diagram as removed from the view of the properties only displayed with the axle direction. Select the show torsion and if the cleared with the torsional diagram removed with the view of the property only displayed with the axle direction. Selected. Show the relative of the angle of the twist, the clear, the relative of the angle of the twist diagram removed from the view. Show angle of the twist of the derivative of the clear of the angle of the twist derivative diagram is removed from the view of the property displayed open section only. Show dimension. If clear, the dimensions are removed from the view. Show extremely. If clear, the minimum maximum views are reviewed from the view. Result type major and minor, major minor, major principal, and minor principal. General. In property and description. General, the distance along with the member of the result of the display for the concrete beams. If the rigid zone of the beam applied with the only if the non-rigid length of the beam of the display with the loading analysis span with the switch with the span with the result of the display shear left of the major minor shear force immediately left of the cross section distance specified. Shear right, the major minor shear forces immediately with the right of the cross section distance specified with the moment of the immediately to the left of the cross section specified with the moment to the right. Major minor moment immediately to the right of the cross section at the distance specified relative to the deflection major minor deflection with the distance specified applied load left applied distributed load with the major minor direction immediately left of the cross section of the distance specified applied load to the right applied distributed load with the major minor direction immediately to the right of the cross section of the distance specified applied force appointed point load with the major minor direction of the distance specified applied momentum applied with the moment of the major minor direction of the distance specified showing load. If cleared, loading diagram is removed from the view showing shear. If cleared, shear diagram is removed from the view. Show for the moment, clear for the moment, the diagram removed from the view. Show for the relative of the deflection, if cleared, relative of the diagram is removed from the view. Show the dimension, if clear, the dimensions are removed from the view. Show extreme, if clear, the minimum and maximum values are removed from the view. Analyst, result of the sign convention. The Tekla structural design is opposite steering convention with the engineer CAD software lowercase x, y, and z represent local coordinate system where uppercase x, y, and z represent global coordinate system. Introductions, axle system, following axle system relevant to software global coordinate system of global X, Y, and Z capitals axis system which all of the system exists. Building directions 1 and 2 of the principal axis of the building, direction 1 being rotated at the angle of the global X horizontal plane. User coordinate system, local coordinate system defined by the system of the user. 1D member to local coordinate system applicable to 1D member to the beams column and the brace of the mid-pier wall coordinate system, local coordinate system applicable to the wall modified by the mid-pier option. 2D member to local coordinate system applicable to 2D members walls and slab. Result line coordinate system, local coordinate system applicable to result lines, result strip coordinate of the local coordinate system applicable to result strip, the foundation reaction coordinate system, local coordinate system applicable to the foundation term of the global X, Y, and Z and local X, Y, and Z axis system as followed with the right hand rule. X axis is the index finger, Y is the control with the middle finger, and Z is the extended thumb, and above the directions is positive VE rotation. Positive vector rotation. X about X is the Y axis moved towards the Z axis. Positive vector rotation of the y z axis moves towards the x axis. Positive vector rotation about z as x-axis moves towards y-axis, or object orientation. Tekla structure that takes into account the object orientation of the display by the analyst result, but therefore to apply with the sign convention correctly, we need to know which of the end of the N1 and which is N2 of the beam wall of the edge. We need to know the face A for the column to determine the orientation of the members group of the scene content with the direction option. Then the Tekla structure design and show the arrow on all beams and walls, and count where the arrow points start at the end of the beams and walls of the draw along with the top of the face. The arrow points at the bottom of the top of the face of face A, looking down with the top of the column face B and C and D with the follow the clockwise direction. Diagram conventions. All arrows should point with the direction of the force of moment. So the reverse vector force of the moments are EGR, force positive force, and negative forces. Global coordinate system, global axis system, applied load directions, FM, MF, MF, MFD, MFX, MFY, resulting deflection distortions, ZXY. Building direction 1 and 2. Building direction applied with the load direction. Global axis vertex, positive vertex Z, vertical only angle between x and direction 1. 0 is positive vector of the right hand rule with about Z. And then resulting deflection directions using coordinate system UCS axis system applied with load direction. UCS can be at any angle of the global coordinate system, and then every support is given in UCS automatically created support with the under certain object with the default with the method of all other supports default with the global coordinate system support with the under single column wall rotates foundational force in line with the Y and Z axis column wall support under the mat foundation using the global coordinate system resulting deflection directions. 1D member local coordinate system, general case of the 1D members, local axis system, local applied load direction, local X all along members N1 and 2, rotation angle Y 0, local Z line, local Z lies placed created with local X axis and global Z axis, global Z component, local Z axis always negative, local Y according to the right hand rule. Y is equal to the positive vector clockwise rotation of Y and Z about X looking towards positive vector X. Applied load direction, load axis system, N1 and 2. Local axis is aligned, shown all above, seeing that the major direction load axis, the local Z plane, positive major direction forces FZ and moment are shown below. Minor directions, the loads of the local XY plane, positive minor direction force FY and moment MZ are shown below. Positive axial force, X local direction, X direction, positive axial moment MX, X clockwise local X is shown below. Result axis system direction, major axis moment major bending about Y, shear major shearing along Z, shows shear moment and deflection. In minor axis moment minor bending on Z, shear minor shear along Y, shear moment moment and deflection. In axial direction, shows axial torsion. Negative and positive. Member end force and direction. Member end force applied with the result of the structure by member. Positive beam end result reaction shown with the beam and the local axis system indicated below. So it's positive beam end reactions. Local axial system Y0. Special case 1D, member to local axis system applied low direction, local X align global Z vertical, the rotation angle Y0, local Y aligns for the global X, local Z according to the right hand rule, Y positive vector close reaction, the Y and Z about X looking towards positive vector X. This is applied directional local axis system column A phase positive end N1 and A2. Applied force direction follow the major directional load axle local XZ plane positive major direction FZ and moment as shown below with the minor direction loads of the local XY plane positive minor direction forces FY and moment MZ that are shown below with the positive axial forces FX axis the local X direction positive axial moment MX and axial clockwise about local X is shown below. Result axial system direction. In major axis at the moment, the major bending about the Y, shear major shearing along the Z, and shows shear and bending. In minor axis at the moment, the minor bending about Z, shear minor shearing along Y. shear and bending axle direction. Axle shows in the two-member local coordinate system, horizontal plane and local axis system, applied load direction, horizontal plane, local axis, local z, normal to the plane panel, where 0, 0, local 0, axis plane over the panel with a line with a global x and positive vertex and positive global, x, local y is plane with the panel horizontal or right hand where 0 is a positive clockwise rotation, x and y about as the axis toward the positive z. Vertical slope panel, local axis system, applied low directions. Vertical slope panel, local axis, local z, normal plane panel where z is 0. Where 0, 0, local z, x is plane with the panel, horizontal plane, y is the plane with the panel, follows the line of the greatest slope of the plane, positive vector direction, positive vector global, 0 vector clockwise rotation, x and y about z, looking toward positive x, slope panel, axis is at 0, horizontal plane, vertical plane, axis is 0, shows, two-member force line convention diagram below illustrates the force inch panel of the 2D element axis for the result. So for the top x face and y face, in plane membrane forces fx, fy, fx, fxy, out of plane plate forces. The arrows show the path of the force direction of the double arrow convention with U with the moment is around with the double arrow of the path of the line being closed clockwise, looking with the arrow to direction forcing the face cut out anywhere with the FE mesh perpendicular force direction, thus force and moment x with the x face whichever the perpendicular x in the moment of result of the spinning with the x direction, the force xz is out of plane shear forcing of the x face, and so with the wood armor design moment is denoted the suffix d active in the same manner with the unprocessed moment without suffix mx dsx, same manner of mx's and so on. The design moment is further to classify the top bottom component for the hugging and sagging respectful slab design process. You may note the path of the xz axis direction followed by the right hand rule is not the same with the 2D member local coordinates of the region with the apparent with the contradiction for the two-member local coordinate system for the applied load direction. Some of the paths applied the load direction convention is negative for z and only negative opposite with the global to the second element axis. Sun convention two-member force is not the same with the first d element of the moment. The positive moment it can create tension on the top surface of the shell, hence the hogging moment of the slab moment over the supporting column is positive while sagging the span of the moment is negative. The convention of the well result is exactly the same with the understanding the exact condition exit direction is interpreted in the same way. Axle load fx and fy are compression is negative. We're not all usually concerned with the sign of shear, however the completeness out of the plane shear fx and z and fyz is positive shear with the moment of increasing the positive x and y direction. Your result line coordinate system centered on the center of the cutting section z aligns along with the result line positive vector negative n2 to n1 y-axis normal plane with the general positive vector to positive vector z direction, special case positive vector x towards positive vector global z, x axis followed with the right hand rule lines on mesh negative x therefore perpendicular cut to the line. The result of the result line exactly the mid-pier model, then cut the horizontal cut direction match the direction required. As a result, resulting axis system and the major axis of the bending of the y and shear along z, the minor axis bending of the z, the shear along y, axial torsion forces x and bending of x. We have the result n1, n2, and then special cases, result line n1, n2, result strip coordinated system center each for the station along with the strip of the center line with the single vary. So for the continuous strip of the z axis of the normal to plane with a mesh for the generally a positive vector to the negative vector of the z global z direction, special case positive vector x towards positive vectors global z x axis along the result strip, positive vector negative n1 to n2, y axis along transverse line strip file with the right hand rule negative y therefore perpendicular to strip line, result axis system deflection negative in this case in the z axis outer plane moment into the y axis shear on the z axis. General case result strip CL with the N1 and N2, special case result strip CL N1 and 2, foundation reaction coordinate system result axis system directions, foundation reaction coordinate system aligned with the coordinate system for the support node of the global coordinate system user coordinate system reactions are force applied with the structure by the foundation. Show the reactions, and then we're moving on to designing guide.